Okay, welcome back to the second section. In this part, I want to calculate critical slope in a prismatic channel, and click on this section and go to the critical slope in prismatic channel section, and the formulas which are used for calculation of critical slope are presented in this section, and you can find more information about the related formulas of this parameter. Okay, let's select the unit of the modeling and enter the flow value, for example 100 cubic meter per second. The bottom width of channel, for example, I have a trapezoidal channel with the bottom width of 20 meter, and the side slope is, for example, about 1.5. The bottom slope is about this value, and the Manning roughness, for example, 0.035 for this parameter, and then press calculate, and after a while model calculates different hydraulic parameters related to these data sets. And finally, based on these outputs and these formulas, the model calculates the critical slope for this case. And if we compare if we compare the bottom slope of our channel with this value, we can find out that our channel has a mild slope, or is a mild slope, because this slope is lower than the critical slope, and so our channel leads to does not lead to supercritical conditions. Okay, this is just for critical slope, and you can use this calculation for river restoration studies, and because in most river restoration case study we want to restore our river based on these values. Okay, let's come back to the first page, and also you can calculate the normal and critical depths simultaneously in the prismatic channel, and we don't have new things to represent, and all of these these items are explained in the previous video. However, you need to select the unit of calculation and enter the flow discharge and bottom width, side slope, channel, bottom slope, and the Manning values, and then press calculate, and the model calculates the normal depths and critical depths, critical velocity, and other hydraulic parameters related to both normal and critical conditions. And also you can use this section for calculation of critical depths for circular culvert or pipe. However, at this time this option does not work accurately. And also you can calculate normal depths in prismatic channel using Shezi equation instead of using Manning equation, and this is one of the most popular formula for calculation of normal depths, but not more than Manning equation. I personally prefer to use Manning equation because it's most widely used method for calculation of hydraulic parameters in most countries and in most researchers and studies. Okay, let's calculate the normal depth based on Shezi equation. For this method, enter the flow value, the bottom width, side slope, bottom slope, and the Shezi C value. Let's search and find the variation of Shezi values. Let me search. However, depends on the bed material. You can find different values for Shezi C coefficient. Okay, let's find. I hope I can find. Okay. Okay, for different channel type and for different Manning values, you can calculate the related Shezi coefficient. For example, for winding natural streams, the average Manning value is equals 0.035, and it equals about 42 for Shezi equation. Okay, let's assume that the Shezi is about 45, and then press calculate, and you can find the normal and other hydraulic parameters which are calculated based on these relatively old-fashioned methods. And finally, you can calculate the normal depths in roadside ditch using Manning equation. For example, road ditch similar to this figure, and the formulas which are used for estimation of normal depths in this case are presented in this section, and all of these formulas are used in different channel previously. Okay, select the unit, enter the discharge value and the side slope Z and side slope Z2 and Z1. For example, for the Z1 I want to enter this value, and for the Z2 I want to enter 2, and also the bottom slope and the Manning roughness coefficient. Press calculate, and you can easily calculate flow depths or normal depths and other hydraulic parameters for this case. And the roadside ditch is one of the most widely used channel type in urban areas, and you can easily calculate different hydraulic parameters for this case without using different and complicated hydraulic models such as SWBM or Flowmaster. Okay, I hope this information and this video is useful for yourself. If you have any question, just keep in touch with me. Have a good time. Bye bye.